Howdy everybody, how's it going? Welcome. Today we're going to talk about U substitutions. One of the big things about U substitutions, it's something you're going to use the rest of the year. I know sometimes you like limits, you're like, I got it. So related rates, it's kind of unique. U substitutions, you're going to use it all the way through integration. You're going to use them on basically every integral you're going to do from now to the end of the course. So I just want to set it up to you that this is one of the more important ideas out there. So we're going to go through just a couple problems to help understand what's going on. Um, let's start with the idea. If I had the antiderivative of square root of x dx, well, I would just rewrite that. I'd start by saying, well, that's x to the 1/2 dx, and I would just do power rule, right? Add a power. Add 1 to that. So I get 3/2. Divide by a power. I now have 2/3 plus c. Not bad. Now, where it gets interesting is, well, what if I had the integral of square root of x minus 5? Well, you might have saw some ways to cheat this on the system, but if you think about it, these are different. They are different situations. Um, and then we'll get into even some more difficult ones in a second. But here's the idea. We're going to do this one problem. So ignore that equal sign. We're going to do this one problem, and we're going to start with this. So first thing you do is you take the terms that you want to get out of there. So u is going to equal x minus 5. Okay? So now if you look at what you now have the square root of u dx. Problem. You can't have dx and u because you can't take the antiderivative of u in terms of something else. So what we do is up here, going back to the u, I take the derivative of both sides. So we got du equals, what's the derivative of x? It's going to be dx, minus 5, so it's minus 0. So what does du equal? Equals dx. So really I have the integral of square root of u du because du equaled dx. So I treat this now the same. U to the 1/2 du, add a power. U to the 3/2, divide by a power, plus c. Last step, you know u equals x minus 5, so you just plug back in. Well, what does u equal? X minus 5. Okay. Let's get into ones that are going to throw a little hiccup at things. So let's say you have the integral of, I don't know, let's say you had 3x minus 7 to the 5th dx. Do you really want to FOIL that out 5 times? The answer is yes. Best of luck to you. For the rest of us, instead we're going to do a u substitution. So what is a thoughtful u for this? U is going to equal 3x minus 7. Look at what I got now. The integral of, instead of 3x minus 7, it's just u now. I got to deal with this, dx. So what we do is we take the derivative. Du equals, what's the derivative of 3x? It's going to be 3 dx. Nice little trick is to isolate the dx. And so to do that, I divide by 3. So I have du over 3. So what does dx equal? See this guy right here, dx? I'm going to substitute in for it. Du over 3. So really I have 1/3 times u to the 5th du. I highly suggest getting in the habit of taking that out because it's going to just help isolate it for you. So when I take the antiderivative of this, I add a power, u to the 6th, and then what do? I divide by that power. So I'm going to multiply it by 1/6 plus c. So what's that equal? 1/18 of u to the 6th plus c. But what does u equal? 3x minus 7. Well done. Well done. So kind of seeing one of the issues that comes up is you're going to have some coefficients to deal with. And so by drawing your u substitution to the side, taking the derivative of it, things are going to be cleared up a little bit nicer versus guesswork. You don't want to deal with guesswork. So let's deal with one that I see a lot. So the integral of 5x times the square root of 3x squared minus 15. Woo-hoo-hoo. Dx. If you think about this, this is the ugly part. That's the part that I need to deal with, because that's that, you see that square root there. I gotta point it the right way up there. I think it's, I don't know, maybe that way. You gotta say, well, u equals 3x squared minus 15. That's the thing that's inside my square root, and so I gotta deal with that. So du is gonna equal 6x dx. Okay? So I now have the integral of 5x square root of u dx. Now, if you notice, I've created a complete mess because I've got u's, I got x's, I got dx's. You can't find the antiderivative of that. So what you need to do is isolate your dx again, because you're going to substitute in for it. So divide both sides by 6x. So dx equals du over 6x. So integral of 5x square root of u. What's dx equal? Du over 6x. So we're just going to write it out. We're writing it out real big here. Square root of u du. All I do is I move my 6x to the left. What do my x's do? They cancel out. And so I have 5, 6 times the integral of u to the half du. Antiderivative. Add a power, divide by a power. So I have 5, 6 u to the 3 halves plus c, but I needed to divide by that power, which is times 2/3. Because if you divide by 3 halves, same thing as multiplying by 2/3. And so I now get 10/18 of u to the 3 halves plus c. But what's u equal to? 3x squared minus 15. Da, da, da. You've done it. Could you check? Yes, you can check after doing u substitutions, but it's going to be a lot of work. Now, things to look for. How do you know you're doing a u substitution? Here's the way I know. Is I have that x squared there. On the outside, if you notice, the derivative of x squared is going to be x times a number. On the outside, I have an x. It's going to cancel that out. Very important. Anytime you see something like this, you're going to have to come along and do a u substitution. So guys, I went and snagged a problem out of, this is out of chapter 4.05, number 37. These are the where you're going to get, and you're going to have to start thinking a little bit more. So what we're going to look for is we're going to look for some pieces to give us hints. I got x squared on top, on the bottom. I have x on the top. The derivative of x squared is x. So I'm going to use that to my advantage. I'm going to substitute. I'm going to do u substitution for the bottom, hoping that it's going to do something to the top. So let's just start. Let's just start throwing some at it, and let's just see what happens. U equals x squared plus 2x minus 3. Now, it's very important. This question said, if dy dx equals that, what does y equal? So it's saying basically, what's the function? Go back a step, what's the function? So we need to take the antiderivative of this to get y. So if I make u equal to that, so really, if I take the antiderivative of dy dx, I'm doing the antiderivative of this. So really, my function is going to be the antiderivative of x plus 1 divided by u squared. There's a dx here, there's dx. I got to deal with those x's, and I have to deal with the u's. And I got to get that dx out of there. So I take the derivative. I get du equals 2x plus 2 dx. So what does dx equal? Dx equals du over 2x plus 2. So I substitute in for dx. So I get y equals the integral antiderivative of u squared in the bottom, x plus 1. What does dx equal? Equals du over 2x plus 2. Now, you need to somehow cancel that. And if it doesn't, we gotta play with it. You gotta try different things. But that is going to cancel it. And so one of the ways to do that is factor. 2 times x plus 1. right? Because if I factor a 2 out of that, my x plus 1s goes away, and I now have the antiderivative of u to the negative 2 du all over 2. I don't like writing it that way. I would write it as 1/2 of the antiderivative of u to the negative 2 du. Now I'm dealing with now I'm dealing with something that's pretty consistent. Add a power. I now have u to the negative 1. Divide by a power, right? So divide by negative 1 is the same thing as multiplying by negative 1 plus c. What is my u equal to? So I've got negative 1/2 u to the negative 1 plus c. What's u? I did a u substitution. X squared plus 2x minus 3. Rewrite it with, here, let's stick it right over here, okay? So you got negative 1/2 plus c over here. And I've got to the negative 1 power means 1 divided by that. If you go back, it kind of makes sense, right? Because if you look at this, when I take the derivative and I have x on the bottom, I usually end up with x squared. I have that thing on the bottom squared, and look what I have. If my original function was x squared plus 2x minus 3 on the bottom, if I were to take the derivative, it would make sense that I would then have a squared up here. Hope that helps a little bit. Hope that gives you a little more focus as you look at the practice problems, and maybe it explains some things. Have a wonderful night. Thanks for tuning in. I love that part.